In this problem, we are given that the base of a triangle is decreasing at a rate of 0.2 centimeter per second, and the height is increasing at a rate of 0.1 centimeter per second. And we are told that the area is increasing. We need to find the constraints on H when the base is exactly 3 centimeter. So first, let's convert the given information into the mathematical equivalent. I'm going to write down this information, that is a base is decreasing. Let's suppose the base of the triangle is B, denoted by B, and the height of the triangle is denoted by H. So therefore we can write down the rate of change of base as dB over dt. Since it changes with respect to time, I write down this as dB by dt, and this is given as negative 0.02 centimeter per second. I put the negative because it is decreasing. And similarly, we can write down this information, that is the rate of change of height by dH by dt, and this is given as 0.1 centimeter per second. Now we are told that the area is increasing and we need to find the constraints on H. So let's write down the area formula for a triangle. If we denote the area of the triangle as A, the formula to find the area of triangle is half of base times H. So I write down this as half of BH. Now let's find the derivative on both sides. So we get dA over dt, and this is equal to half of, here we have to use the constant multiple rule. So we will not have to find the derivative. 1 by 2 is a constant, so we keep that as it is, and then we apply the product rule to find the derivative of pH. Because both are varying, we apply the product rule. So in product rule, we find the derivative of one of the variable. I find the derivative of b, and then multiply with the other term as it is. Now plus, we have to add the plus, and then we find the derivative of the other variable, that is dH over dt. We find the derivative of h with respect to time and multiply with the variable which we have not find the derivative. So therefore it is b. Now we can substitute the values which are given. I'm going to substitute dB over dt as negative 0.2. So let me do that. So this equals half of dB by dt can be substituted as negative 0.2 times of h plus dH over dt is 0.1 times of b. So this is the equation that we have. Let's simplify this. So this equals, I'm going to distribute this half into this two terms inside the brackets. So therefore this becomes negative 0.2 times of h by 2 plus 0.1 b over 2. We can simplify this. So therefore this becomes negative 0.1 h plus this becomes 0.1 by 2 is, this is 0.05 b. In fact, we can substitute the value of b which is given in this problem. We are given that b equals 3 centimeters. So I'm going to substitute that here. So therefore this becomes a negative 0.1 h plus 0.05 times of 3. So when you multiply these two, we get negative 0.1 h plus 0.15. Now we are also told that the area is increasing, which means this quantity dA over dt, that is the rate of change of area, this has to be greater than 0. dA over dt, this has to be positive. Only then we say that the area is increasing. So we utilize this condition, and this means we now have an inequality, that is this quantity is greater than 0. So from this we can solve for h. Let me do it here. That is negative 0.1 h plus 0.15 greater than 0. So this is the inequality that we have. To solve for h, I'm going to subtract 0.15 from both sides. So I do it like that. So we will have negative 0.1 H greater than negative 0.15. Now I divide both sides by negative 0.1. Remember that in an inequality, if you divide by a negative number, we have to flip the sign. So this sign, this inequality sign has to be flipped. So I'm going to divide by negative zero point 0.1. So I write down negative zero point 0.1 divided by negative zero point 0.1, and we will also have to flip this inequality sign. Therefore, this becomes H less than negative 0.15 divided by negative zero point 0.1, and this is equivalent to 1.5. It's a positive 1.5. So finally we got the constraint for H, that is H has to be less than 1.5, and this means the correct choice is D.